These are my flowers that I create. Let's show you some of my examples here. And the vase is also coated in TurtleStitch too. Okay, let me share my screen and go to the slideshow. Here we go. Coating flowers in TurtleStitch, from curves to a paper cut design. TurtleStitch isn't just for embroidery, it's a gateway to mathematical art. By combining precise geometric programming with hands-on making, I developed a process for turning algorithmic flower designs into physical paper creations using the silhouette cameo. Today, I'll show you how I design the flowers using simple formulas, petal blocks, and rose curves, the math behind the patterns, how I exported and cut them with the silhouette cameo, how I created paper vases using TurtleStitch designs. TurtleStitch flowers are built on geometry and rotational symmetry, whether petals are curved, straight, or custom shaped. Each design relies on fitting elements evenly around a circle. Each method reveals how math can lead to surprising and beautiful results. Designing petals with the arc block. Drawing curves with turtle graphics goes back to the early days of logo. Cynthia Solomon, Seymour Papert, and others knew that straight lines couldn't capture the beauty of curves in nature, so they added arcs to the turtle's vocabulary. TurtleStitch continues the legacy with its arc block. Students can create flowing, curved petals with just a few simple commands, as you can see on the right, thereby discovering how code and geometry are connected. The petal block. Creating a custom petal block allows you to generate complete flowers with just two inputs. Radius controls the arc size, the degrees sets the arc angle. Each petal uses two symmetrical arcs connected by 180 degrees minus degrees turn, which is the key to maintaining perfect symmetry. This works because 180 degrees represents a straight line, causing the turtle to flip across the center line and mirror the first arc. The pattern then repeats around the circle with petals spaced using 360 divided by the number of petals. Another version of the petal block. If you replace the 180-degree turn with a different value, you will get a lopsided asymmetrical petal. I developed a formula to compensate for the differences. So it's going to be final turn equals 360 degrees divided by the number of petals minus 2 times the arc angle plus the inner turn. This formula accounts for three things: the total angle the turtle turns while drawing both arcs, the sharp turn between the two arcs, the final adjustment needed to evenly space the petals around the circle. When the turtle's rotation doesn't complete a full circle, adding 360 degrees ensures it's properly oriented for the next petal. This technique maintains perfect symmetry regardless of your petal design. This lets me design with intention and flexibility. Point to your flowers and point to your petals, rounded petals, and even more. Designing a variety of flowers with this enhanced petal block. Using that final turn formula and determining if the final turn is less than 360 degrees, I'm adding 360 degrees, I can make a variety of petals. And here are some of the values that you would put into these set number of petals: radius, arc angle, and inner turn. And these are the type of flowers that can be created with this code. A straight line petal. Now let's try a different approach entirely. Straight line petals rely on interior angle calculations. The turtle draws one petal and then uses this formula. The interior angle equals n minus 2 times 180 divided by n, where n is the number of petals to align the turtle for the next petal. In this diagram, x is the rotational angle or the external angle, and y is the internal angle, the measurement needed for placement of the next petal, because it tells the turtle exactly how much to turn to face the correct direction. From a straight line petal to custom designs. Building on this straight line equation code, we can create more expressively designed petals by replacing each straight line with a series of smaller moves and turns. This lets us customize each petal's shape, making them curved, wavy, or zigzagged while keeping the petals evenly spaced around the flower. Notice that the minus 50, 100, and minus 50 all is 0 here, and then that turn is 180 degrees, and then over here it's minus 50, 100, minus 50. Again, the total here is a turn of 180 degrees. This keeps the flower symmetrical and ensures the turtle automatically faces the right direction for the next petal without any manual adjustments. The Move It Spaces block handles drawing these detailed petal segments using a small moves and turns. Curving the equations, petals with arcs. To create a curved petal, we insert an arc into the middle of the straight lines. In this example, the arc uses 120 degrees, and you see there's 120 degrees here. Since a complete petal needs a turn of 180 degrees, we subtract the arc angle, 180 degrees minus 120 equals 60 degrees. This remaining 60 degrees must be split equally between the two sides of the arc. 60 degrees divided by 2 equals 30 degrees. So the turtle turns 30 degrees before the arc. So here it is, 60 minus 30 is 30. And then it moves another 30 degrees after the arc. And this will produce a smooth, natural-looking petal because the turtle gradually enters and exits the curved section, ensuring it draws a symmetrical petal and ends facing the correct direction for the next petal. Designing flowers with rose curves. Rose curves takes an entirely different approach. One mathematical formula draws the complete flower in a single flowing motion. The rose curve formula is R equals A, which is the amplitude, times the sine of n times theta. And for this example, above, the slider value for the amplitude is set at 100, and the n slider value is 6. This creates 2 n petals, or 12 petals. When n is an even integer, 2 n petals are produced. An odd integer produces n petals. And you can see the rose curves here from 0 to 7. Exporting rose curves from TurtleStitch to the Silhouette Studio. Once the design is created, I exported the rose curve from TurtleStitch as a DXF file. That's the blue line here. And open it in Silhouette Studio. I offset the design outward by 0.02 inches. And then apply an internal offset of 0.02 inches to cancel out the original offset. This technique creates a flower shape that preserves the center, preventing it from being cut out because the blue lines would otherwise be cut lines. I use this offset technique with all of my flowers. From code to craft, creating paper vases. To make a lacy flower, I export the design from TurtleStitch as a DXF file. In Silhouette Studio's offset menu, I applied an internal offset of 0.075 inches to the entire design. Then I added an external offset of 0.075 inches to just the outer line of the flower. The interior petals were enlarged by 125%, and the center circular piece was removed. And the blue line flower shows the original DXF file from TurtleStitch, and the red line flower shows the modified version created in Silhouette Studio. The result is a lacy flower that was added to this dodecahedron vase. Continuing my quest to make flowers, I used an arithmetic spiral, and I created this rolled paper flower. It starts on the outside of this of the spiral, and it goes inward as the circles get smaller. And I've made many different types of designs at the edges of this spiral to create these flowers. And once the flowers are rolled up, they create a rose. A torus is an entirely different type of flower. A torus is made up of Villosuru circles. 16 Villosuru circles make an entire flower. And what I've done is the Villosuru circles have slits in them, and they slide into each other. And that's how the spiral design is created in the interior of this flower. And here's a Villosuru circle, and I've just modified it. I've just taken a portion of the Villosuru circle, and I modified the edges in this design. The versatility of coding. TurtleStitch combined with the Silhouette Cameo provides both precision and creative freedom. With just a few blocks, I can quickly generate complex, symmetrical designs that would be tedious and time-consuming to edit point by point with the Silhouette software. The ability to export these designs directly as cut files allows me to move seamlessly from code to paper. TurtleStitch becomes more than a design tool. It's a time saver. It frees up time for me to focus on creativity, experimentation, and making. And here are some of the designs that I created, the flower arrangements and their the vases that here's that lacy design that I created in TurtleStitch, and I made it part of the vase. And here's another one. So thank you very much. I hope you enjoyed exploring mathematical beauty of coding flowers, and my TurtleStitch projects can be found on the TurtleStitch website, and my name is Elaine. And I have two blogs. I have a papercraftetc.blogspot.com and turtlestitch.blogspot.com, and you can find more fun projects featuring math-based designs there. Thank you.
I wanted to ask Elaine, how do you come up with, I don't even know how to ask this, like you come up with 2D shapes that were, when bent, transform into 3D shapes. How do you come up with this? How can I learn how to think that way?
You just modify the edges of the, like for the example on this torus, I just modified the edges, and then I just play with them just to see how they come together. So now the slices are going to be slid into one another. So I tried to make it symmetrical, and actually it starts out smaller and then it gets larger. So I just play around with the edges and see what looks good.
But do you start with an idea of what the 3D shape is going to look like, or do you start?
You know what? I actually can look at a flower and then decide, like, what does this flower look like? There's different forms that flowers create. There's carnations and there's daisies, and just try to recreate the different images or the designs that the flowers have. And then after a time, it starts I've got hundreds of flowers that I've made. And it's just amazing what you can create. So that's why I say it's a wonderful way to teach math because there's so many different varieties of flowers, and no two students are going to have the same flower at the end of a session, of coding. So that's what makes it so interesting and unique.